My name is Chemi, and I'm here to speak with you about the recipe of runtimes. I'd like to introduce you with what lies in between Node and V8. So quickly to introduce myself, as I said and Kirill said, my name is Chemi. I work at Autofleet. I'm the Frontend Tech Lead. I additionally maintain and collaborate in a few open source projects. This is just two of them. And just quickly before I start, I'd like to say that I'm not here as a representative of the Node project. I'm here with my own opinions. And with that said, let's start speaking. So we're here for a Node.js conference, but we probably all heard of at least one or two more two runtimes, JavaScript runtimes, that have been floating around recently. And we should be asking ourselves what the differences between them are, what are they trying to do better than one another. And in order to answer that, maybe we'll go backwards and try figuring out what Node.js actually is. So in order to figure out what Node.js actually is, let's take this cryptic quote from the Node.js website, which says that Node is an open source, cross-platform JavaScript runtime environment. So that doesn't tell us much if we don't know what a runtime environment is, so let's figure out what a runtime environment is. So a runtime environment is a program that allows us to execute our code. It's a platform for running our program, which provides us with tools to manage memory and to interact with the operating system, whether that being reading file system or HTTP requests or any other thing. So Node, and we just mentioned Deno and Bun, we showed Deno and Bun earlier, are just a few of the runtimes that come to mind or that exist. So Node, Deno, Bun are all out there in the wild, but also the browsers are JavaScript runtimes. They're actually the original JavaScript runtimes, because they also give us the ability to interact with the operating system and, well, to the scope of what the web APIs allow, they provide us with abilities to interact with the operating system. React Native is also a JavaScript runtime. It provides us the ability to interact with native operating systems with native applications. We also have Napa.js, which is actually a pretty interesting project. It's a Microsoft project which is aiming to create a JavaScript runtime for true multi-threaded programs. There are all kinds of others. Most of them are probably like just fun learning projects. Some of them I can't even actually pronounce. And there are Cloudflare workers, which are aiming to solve a very different problem than some of the others. They are aiming to solve the running JavaScript and running JavaScript servers on the edge. So if we're saying that all of these are just JavaScript runtimes and they allow us to execute our JavaScript, so why do we have so many of them? What are they all different from one another? And what does each one of them offer which is unique and different from the others? So I could just answer the question, but then I would have nothing left to do with the next 25 minutes. So instead, let's just start talking about restaurants. So I'd like to introduce you to Yossi. He's a chef at the Chicken Station. And as a chef in the Chicken Station, he has knowledge of cooking. He knows the science of cooking. He knows how to combine different ingredients together. And he's a very good chef. He learned, he has an actual diploma, and he also has the ability to create very good schnitzels, and he can keep creating many of those as long as he still has the ingredients for them. Alongside him works Avi, the kitchen manager, who's in charge of making sure that things keep flowing as they're supposed to. He manages the order slip. So if you order something, you get your slip, you have to go, you stand in line, and things keep flowing in the right order. And I don't know if specifically Chicken Station has this ability, but bear with me. The kitchen manager can also allow you to order, and he will make sure that if you pre-order, for example, a pizza for 7 p.m., your pizza needs to start getting prepared early enough so that it's ready on time, but not too early so that you don't eat your pizza cold. And you know how like people cut the line? I mean, I know in Israel that never happens. People don't cut the line, but some people just think that they are VIP customers and they cut the line. So the kitchen manager also needs to make sure that VIP customers get the resources they need. They need to be pushed up to the top of the line. They need to be served before other customers are. Now, in the chicken station, they have a rotisserie making sure that the chicken is ready and that you don't have to wait. Now, they put the chicken in there and they can go ahead and do other things, and they're not required to stand and wait for the chicken to be prepared. And I know I work in a place in between two different branches of Chicken Station, and although they both serve the same dishes, they look very different, at least from outside. And once it's, like if I leave the office 5 minutes too late, then I'm standing and I'm in the back of the line and things start piling up. It's just a crazy line. So another thing that I don't know if Chicken Station has, but bear with me again, is lunch specials, right? So you can order your food and you'll get in one meal you order, you'll get both the starting dish, the main course, and a drink, for example. And you can keep ordering, right? If you really love your schnitzel and you're still hungry, then good for you, but you can order more. And in our office, we're in between two different branches of Chicken Station, but one of them we really dislike. We feel it just works way worse than the other. And so we have a rating of different branches of different restaurants, and there's also Google Maps, right? So I can see comments and ratings of these restaurants. And so you know how sometimes Chicken Station branches get closed because they did not stand the regulations required? So I go to eat somewhere, I prefer to know that they're standing with the regulation and they are up to whatever the regulation, especially health regulations, require. So I've been speaking about this for, I don't know, 3, 4, 5 minutes now, about restaurants. And by now you're probably asking yourself, am I in the wrong hole? What's going on here? I came to hear about JavaScript, you're just babbling about food. What's going on here? So what if I told you that a JavaScript runtime is basically a kitchen? So over the next few slides, I'd like to break that into an explanation of what a JavaScript runtime is built of, and we'll see how it actually behaves kind of like the kitchen we described. So I'm going to name the building blocks I see are 4 pillars if you want, and we'll then later start diving into each one of them. So every JavaScript runtime will have some program that can parse and execute the JavaScript code. That's the JavaScript engine. And every, or almost every JavaScript runtime would require an event loop. And we said that part of the definition of what a runtime, a JavaScript runtime is that it allows us to interact with the operating system. So we're going to have I/O APIs. And every runtime needs to provide us some kind of module system so we can interact with more than one file and keep importing things throughout the life cycle of the application. So let's dive into the JavaScript engine. So we spoke about Yossi, the chef in Chicken Station, and we said how he knows the science of cooking. So the JavaScript engine has the, if you'd like, science of JavaScript. That's the JavaScript specification, ECMA 262. And just like the chef can have a diploma, the JavaScript engine can execute against a test suite called Test 262, which is a compliance suite, which is part of the JavaScript specification. You need to, every new proposal has to add tests. And every JavaScript engine can execute those tests to show how compliant it is or isn't with the JavaScript specification. Additionally, right, just like in the chef, he knows to work with specific ingredients and he can keep creating those dishes. So in JavaScript, you have the keywords and the functions which are built into the language, and you can keep ordering additional dishes with your code which is using those ingredients. So we covered the JavaScript engine, the chef. Now moving on, let's speak about the event loop. So the event loop is related to Avi, the kitchen manager. So we spoke about how the kitchen manager is in charge of the task queue, making sure that tasks happen when they're supposed to, and that things don't start getting lagging behind one another. So that's our JavaScript task queue, right? We run code and we run lines one after another. Each one of those lines, or each chunk of lines, adds a new task to the queue, and the event loop is in charge of executing those one after another. Now, we spoke about adding a pizza, right? So the event loop also provides us with the ability to add timeouts, intervals, to have callbacks. And we spoke about VIP tables. So in JavaScript, we have some kind of a VIP kind of task that is being pushed to the top of the queue. That's what's called microtasks. Promises are such a type of queue of task. And we spoke about pushing things, about how Israel is pushed to the top of the line. So we also have queue microtask, which allows you to explicitly push other tasks to the top of the line. Let's see if this works. It doesn't work, so we'll skip it. I'm not going to go deeply into the event loop, but here are some really good tutorials or real good sessions that speak about the event loop. If anyone finds it interesting, I really recommend the Jake Archibald session. And also Lydia has a really good session. So we spoke about the JavaScript engine and about the event loop, the chef and the kitchen manager. And moving on, let's speak about the Runtimes-IL APIs. So remember how we said that the kitchen has a rotisserie that you can put the chicken in and you can go and come back? So that's kind of like non-blocking tasks, right? If I send out a HTTP request, my event loop isn't blocked on the HTTP request. I can keep doing other things. My code can continue executing other tasks while that's happening. Additionally, we said that every kitchen is somewhat different and they don't all look the same, right? Different branches look different. So each JavaScript runtime will have its own APIs, and while they, for example, Bun and Node both give me the way to read files, they propose different APIs. They have different ways to do that. And additionally, we have every kitchen, right? We spoke about how it starts lagging when it's the rush hour and like I stand more time in the line. So my runtime is limited by the environment's capacity. If I only have one core of CPU, I can never do more than what that core can handle at once. Moving on to the module system. So we spoke about how like we know in the office which branches we do or don't like. We have Google Maps recommendations. So in the JavaScript world, we have a JavaScript registry, whether that is GitHub, where I can go and see how many issues or how many forks or stars a repository has. We have the NPM registry, which tells us how many weekly downloads there is to different packages, right? So that's that. We also have the launch special. If I import a module, say if I import Lodash, it comes with a bunch of things. I can do many things with that one import. And I can keep importing dynamic imports, right? I can keep ordering additional dishes throughout the life cycle of my application. And last but not least, we spoke about health regulations. So finally, after quite some time, ESM has turned into an actual standard, and it's finally, Benji's laughing because he doesn't like ESM, but finally it's standardized and it's shared between all the JavaScript runtimes. So we covered all the 4 pillars, but still, we don't have any good explanation for why we have so many different runtimes. What's the reason we need all of them? So I would just like to emphasize that just like if I take the same chef and put him in different kitchens, I'll get completely different meals. So the JavaScript engine, right, the part of the code that is executing our code, it does not define the runtime. The kitchen built around it, the runtime built around it, that's what defines it. So we spoke a bit in the air, now let's see this in practice. So Node and Deno, both written by the same guy, Ryan Dahl, both use the V8 engine, which is part of the Chromium project. And each one of them uses a completely different tool for running the event loop and for its I/O APIs, right? So Node uses libuv, and Deno uses Tokyo, which is part of the Rust ecosystem of async tasks. And Bun, which was created by Jared, is attempting to basically do everything in-house and do everything quickly. And I won't get in deeply to different controversial subjects about what Bun does better or worse, but it uses completely in-house utilities for the event loop and I/O APIs, but it uses a different engine. It uses the JavaScript core, which stands behind Safari. And module system, ESM, is the same for everyone now that it's standardized. So we spoke about the runtimes. Now I'd like to play a quick game. I'm going to name an API or a name of a function, and I'm going to want you to raise your hand if you think that it's something implemented by the JavaScript runtime, or if you think it's implemented by the JavaScript engine, if it's part of the JavaScript specification. So if it's, when I reveal the answer, I'll show you the JavaScript logo if it's part of the JavaScript spec, and the Node logo if it's an external API. So, quick example, the error method, the error class. Raise your hand if you think it's implemented by the JavaScript engine, if it's part of the JavaScript class, part of the JavaScript specification. Right, so error is built into the JavaScript language. So set timeout. Raise your hand if you think this was implemented by the JavaScript runtime. Raise your hand if you think this is implemented as part of the language spec. So remember how we said that the kitchen manager, the event loop, is in charge of the timeouts and stuff like that. So that is implemented by the runtime. Specifically in Node, it's implemented using the timer utilities that we have from libuv. And moving on, promises. Are promises implemented by the JavaScript engine? Are they part of the language? Awesome. Raise your hand if you think they're implemented by the runtime. So promises are built into the language. There were times where they were external APIs. Maybe you know of Bluebird or other old-fashioned libraries. But they have finally, a long time ago, but they have been added into the JavaScript language. Moving on to the fetch API. Raise your hand if you think it's part of the JavaScript language. Raise your hand if you think it's part of the JavaScript runtime. So fetch is part of a spec called the fetch spec. It's not part of the JavaScript language. Some of you might remember that a few Node versions ago, around 18, it was been added with no flag, while it was already a long time existent in the browsers. Moving on to the console API. Raise your hand if you think the console API is part of the JavaScript language. Raise your hand if you think it's implemented by the JavaScript runtime. Right, so the console API is implemented by the runtime. Moving on to the global this object. Raise your hand if you think the global this object is implemented as part of the JavaScript spec. Raise your hand if you think it's implemented as part of the JavaScript runtime. So the global this is implemented as part of the JavaScript language. It's part of the specification, aiming to combine the two different objects, the global objects being global and window, that were split between Node and the browsers. And this was an attempt to help write the same code once while working both in the browser and in the runtimes. So add event listener. Raise your hand if you think this is part of the JavaScript language. Raise your hand if you think it's part of the JavaScript runtime. So add event listener is part of the runtime. It's part of the DOM spec. It's event listeners that are attached to HTML elements. Moving on to queue microtask. Raise your hand if you think this is part of the JavaScript language. Raise your hand if you think it's part of the JavaScript runtime. So you're correct. This is part of the runtime. It's part of what the event loop allows us to do. I'm pretty sure that this doesn't exist in the browser, but don't beat me up if I'm wrong. And moving on, the set, the unique array class, is that something that's built into the JavaScript language? Raise your hand if you think it's part of the language. So I see most of the people are raising their hands. Yes, this is part of the language. Okay, now I'm just messing around with you. The node object. Raise your hand if you think the node object is part of the JavaScript language. Raise your hand if you think it's part of the JavaScript runtime. I'm speaking about the node element, which is part of the objects of the DOM, and not about the node runtime. Sorry, I just had to put this in. Moving on to the disposable. Raise your hand if you think disposable is something that's part of the JavaScript language. Raise your hand if you think it's part of the JavaScript runtime. Now raise your hand if you didn't hear of disposable before. So disposable is a new thing coming into the JavaScript language. If anyone is interested in a summary, here is a summary of what we just went through. And I'll speak about disposable in a minute. I'll just let people finish taking pictures. So the disposable, and this is a quick detour because it's not really related to JavaScript runtimes. It's part of the JavaScript language, as I said. But the disposable is part of a new proposal being added to the JavaScript language. It's a stage 3 proposal. It's attempting to solve the issue of managing resources. So for example, consider you want to open a short-living server, and once you're done with it, you need to clean up after you the resources that you opened. So that's what it's attempting to handle. So it introduces a new keyword, the using keyword, and it also adds 2 global symbols, the well-known symbols, the dispose and async dispose. So here's a quick example of what this looks like. This is a oversimplification, right? So if I would want to open a file handle that would allow me to read or write to the file, I would normally wrap it with a try finally, and in the finally, because I want to handle this whether it succeeded or failed, I would close that resource, the file handle. Moving to explicit resource management to disposable, that would allow me to just use the using keyword, and I would remove all the boilerplate, and once the file handle exits the scope, once this function, in this case the handle file function is done, I would have the file handle automatically cleared up, and the resource would be cleared up. So that's awesome. That means we write less boilerplate. We have error cases handled for us. But how does any of that help us if we need to wait for the JavaScript runtime, the JavaScript engine to implement this, right? So we said it adds a new keyword, it adds new symbols. So why am I telling you all of this, and what can you do? How could you use it? So the question to be asked, and as a collaborator in Node, the question to be asked is, what can we do to help bring this further and bring this quicker out to the users? So we can't actually bring this out to the users quicker because we don't parse, Node doesn't parse the JavaScript you execute, right? That's something that V8 is in charge of. What Node can do, and it actually did, was to implement a polyfill for these symbols. So sitting here up front are Moshe and Benji, which added those symbols into Node. I'm sorry, I don't remember what version that was in, but the symbols were added into Node, and that's super cool, right? But that doesn't actually help us because we still can't do anything with those symbols other than just keep calling them in the finally, right? So what value does this actually bring? So this is where transpilers come into the rescue, and Babel and TypeScript collaborated with the Node team here. So as I said, Moshe and Benji implemented the polyfills for these symbols, and the 3 of us added this behavior and the symbol onto a lot of the Node APIs. And what the transpilers did was to implement a utility, right? So when you write using keyword, they make sure that it's transpiled into a function that actually does this wrapping for you. So going back to the JavaScript runtimes, I would like to try and classify JavaScript runtimes into 3 main types of runtimes. So, as I said earlier, there are projects which I can't even pronounce their name. These are mostly projects which are people experimenting, trying to learn or playing for fun. I wouldn't use these in production, but if that's what makes you happy, then I wouldn't like to be your boss. There are runtimes which have a specific use case. So we spoke about workers, Cloudflare workers, which attempt to solve the issue of running JavaScript on the edge. And there's React Native, which solves a very different issue. We spoke about Napa.js, which is attempting to provide real cross process, and there is IoT.js, which is completely different. It's trying to create a JavaScript runtime which has a small memory footprint, so you can run your code on devices like washing machines and refrigerators. I have no idea why anyone would like to do that with JavaScript, but that's possible if you'd like to. And there are the, if you'd like to call them mainstream, there is Node, Deno, and Bun. So Bun is attempting to solve everything in-house, like they're trying to be a bundler, a test runner, and they're not exactly doing the same thing like Node and Deno, but they are trying to be actual competitors with them. So those are the mainstream runtimes. And I think that if I need to summarize in one sentence is that, as we said earlier, same chef, different kitchens, right? So you can have the same runtime, the same JavaScript engine in different runtimes, and it would not be the same runtime. And JavaScript ecosystem is built over many building blocks. So every piece of the runtime, every piece of this program is going to have some alternative, and you should pick the runtime that you're going to use based on what you're actually attempting to solve. And I think this is a good point to remind everyone of the Atwood's law that says that any application that can be written in JavaScript will eventually be written in JavaScript. Thank you, everyone. And if anyone has any questions, I'm here. Catch me off stage.